Okay, so now we are going to study a very important concept with LLMs called quantization. Now, again, if you visit the llama.com website, you'll see that at a lot of places you'll see the word quantized. It says Llama includes multilingual text only models like 1B, 3B. Now we understand what these B stand for, which is billions of parameters, including quantized versions, right? And if you try to check further, you'll see that they also announced something like Llama 3.2 with 1 billion and 3 billion models as quantized, right? So you can read through it. It says that it increases the speed and reduces the memory footprint. Now, again, if you visit the Ollama website, previously we visited Llama, now we visit Ollama, and you look for any specific Llama models, you'll see some mention of the quantization like Q4, KM, F16. Now, what is quantization? Let's take a look. So, quantization is a process of reducing the precision of numbers used to represent a model's parameters, right? Now, I think we studied at length what are these model parameters. Now, by now, I think you can easily state that these models parameters are nothing but the weights and biases. So what quantization says is that instead of storing a number, especially a floating point number as a 6.66, why don't you store it as a 6? Instead of storing a number like 13.65, why don't you store it as 13? So in a way, quantization is nothing but a kind of compression, right? It is a kind of compression, but what we are doing in this is we are storing a specific number in a specific format, and we are reducing the precision of that number. So if you see, from 72.56 we've gone to 72. So quantization is a process of reducing the precision of numbers to represent a model's parameters. Now, quantization in AI reduces the number precision to make the model smaller and faster, obviously, right? If you look at it, if this is 6.66, I could even store it as 6.66543 if I'm talking about a floating point 32, which is like they say that the default floating point that the models or LLMs use is floating point 32, right? So think about it, that if I'm storing in such big numbers, obviously my model would be a larger model, right? It would need more computation. But it's the other way around now. We are saying I'm reducing the precision, which is making my model smaller and faster because it needs less computational resources. So an example to understand could be like, it's a real world example or a normal example, not with LLM, but we are just saying that compressing a high quality image to a smaller size. This is kind of quantization. Now, question arises, but why it's important? Why it's important? Because it reduces the model size. Now, it's very important to reduce the model size, especially when you talk about bringing the models or LLMs to your own hard disk or bringing your LLMs to your local storage, right? You want the models to be smaller. So quantization helps with that. So it helps to reduce the model size to make it smaller so that they take up less memory. Pretty self-explanatory. If a model is small, it will take less memory, it will need less computational resources. Same thing, it speeds up processing because your calculations would be simpler and your model will run faster. Obviously, if a CPU has to do less work, your models will run faster. It saves energy, very important, right? Because it will use less computing power. Previously, when I was storing large numbers, obviously you were doing a lot of computation. Now you're doing much less computation. And if you're doing much less computation, you're saving energy, right? Which is great for devices like phones or edge devices, right? Now, it's a very simple example I've taken. I'm giving you an example, right? So let's say we're talking about a number 12.34. Now, when you see FP32, it means that it is in floating point 32 precision. Now, if you store this number in floating point 32 precision, it would be stored as 12.5625. Now, if I apply quantization to it, I'm saying, let's say you quantize it as a 6 or as an 8-bit integer. So this same number, which is 12.5625, will be stored as 12. Very simple or similar to the example we studied. Here also, you can see I'm using a floating point 3452. This is a 32-bit floating point. If I have to store it as 8-bit, it would be stored as number this, right? So this is nothing but quantization. Now, always remember, there are always certain trade-offs with quantization. The trade-off is slight accuracy loss. Why? Because something you were depicting as 6.6643 is now being depicted as 6. Obviously, there would be some loss in accuracy. And this adds up because this is not only one number. All the different weights, biases that you were storing previously in high precision numbers are you are storing in low precision numbers. So there is some reduced, reduce or loss of accuracy. So reducing precision may cause minor errors, but modern techniques often minimize this, right? So there is a slight accuracy loss, but with that accuracy loss, obviously you need to do some more further training, right? So you need to train your model. So let's say you train your model with these numbers. You'll have to do the training again. So train the model again, right? Because you need to see that with these numbers, how the model behaves, right? So some more level of training or complex training would be needed to adjust so that you ensure that even with this level of quantization, it works. So it's very similar in that sense where Llama guys say that we had the 3 billion and 1 billion models, and now we are giving you as quantized models, right? So how a 1 billion or 3 billion used to behave previously should behave the same way in a quantized version, right? So I think now with this lecture, you got a very, very good understanding of what is quantization, why it's important with LLMs, and later on you'll see how Llama models are quantized and how Llama uses the quantized models as well. Thanks for watching.